Section 2.6. 2.6 objectives. Find the domain of a function. Combine functions using the algebra of functions, specifying domain. Form composite functions. Determine domain for composite functions and write functions as compositions. Okay? So, let's talk about finding domain first. Okay? I also got new pens. They are fine point. Yes. Yes. They were a present. Okay. So let's start off with this function. F of x equals x squared minus 7x. What is the domain of that function? Well, what type of function is that? That is a parabola. Okay, so think about what a parabola looks like in your head, and what's the domain going to be? Yep, all reals. Got it? What about this function? F of x equals 1 over x plus 5. Can you remember what kind of function that is? It's a rational function, which means there's two parts to it, right? There's an asymptote involved. How do we go about finding that asymptote? So I set the denominator equal to 0 and solve. And that tells me where the domain is not, right? The domain basically is going to be everywhere except that place. So we could say all reals x does not equal negative 5. Or we could say negative infinity to negative 5 union negative 5 to infinity. What about this? F of x equals the square root of 3x plus 12. What you got? These things underneath the root sign, are they allowed to be negative? If it's negative, we'd have the I, right? And we're not going to deal with that right now. So I need to set whatever's here equal to 0 to start with. 3x plus 12 equals 0, so subtracting 12. 3x equals negative 12. So x equals negative 4. So that kind of gives me a starting point, right? Anything less than this will give me a negative number underneath this. Does that make sense? Think about what a square root function looks like. Like that, right? So this tells me I go 1, 2, 3, 4, like that. It's not exactly true, just for the record. This is actually a really bad graph. Okay? Because this is really, well, no, that's not true. This is a good graph. This is a horizontal shift, right? It's moved to the left 4. So what I have to figure out is how am I going to write my domain? I know it has something to do with negative 4, but is it like this, where x is not negative 4? Or is that the starting point of what my domain is? It is. Okay, so x is going to be greater than or equal to negative 4. It's allowed to be negative 4. If I put a negative 4 in here, I just get 0, and I can take the square root of 0, can't I? So I would say negative 4 to infinity. Except this is wrong. Tell me how to fix it. Good. Let's do one more. What about the domain for this? The denominator of the fraction is not allowed to equal 0, right? So x squared minus 2x minus 3 equals 0. I set this equal to 0 to find out where the domain is not. Okay, so I would need to factor this minus 3 and positive 1, and then set each one of these equal to 0 to get x equals 3 and x equals negative 1. So this tells me where my domain is not. So first of all reals x is not equal to negative 1 or 3. But if I'm writing in an interval notation, I want to say from negative infinity to negative 1, and then again from negative 1 to 3, and then again from 3 to infinity. Okay? Okay so far? Yes? How do you feel about finding domain of a function? Pretty comfortable? Excellent. Second objective for us today is combine functions using the algebra of functions specifying the domain. Okay? So we did this definitely in Algebra 2, and we just called it operations with functions. First of all, I said to you f of x equals 2x and g of x equals x minus 1. That's what I told you. Okay? Then I said, please find f plus g of x. Well, how are we going to do f plus g of x? You're thinking of something that's next, but not yet. Yeah, that's fogging off. Yeah, just add them together. F plus g of x. So, perfect. And then what it also wants you to do after that, right here, specifying the domain. Once you get your answer, you have to think about what this new type of function is and specify the domain. So what's the domain of this new function? Because it's a line, right? So our numbers. Got it? Okay. What about f minus g of x? Subtract them. So 2x minus x minus 1. Well, 2x minus x minus 1 is actually 2x minus x plus 1, isn't it? Which is perfect. That is a line, so my domain is perfect. Guess what's next? F times g of x. 2x times x minus 1. So we just need to distribute 2x squared minus 2x. What shape is that? A parabola. What's its domain? Perfect. F over g of x. 2x over x minus 1. Okay, done, first of all, right? There's nothing I can do to simplify that. I just have to come up with this domain. I come up with the domain by... do I have to write that, or can I do that in my head? So all reals except for... yeah. Do I need to go over interval notation for all these, or are you okay with that? Okay, let me just do it real quick so that we have it in the notes just in case. Okay, all reals is just negative infinity to positive infinity. So those are all pretty easy. The only time people ever get tripped up on it is this last one. Negative infinity to 1 and 1 to positive infinity. It's everything but the 1. Okay? Now, let's do some compositions of functions. Okay? Compositions of functions says we're not adding, subtracting, multiplying, or dividing. What we're actually doing is we're saying f of g of x. Okay? Now remember, this used to say f of x, so that means anywhere there's an x, I'm going to write a g of x. So this would really look like 2g of x. We're using the same functions that we talked about before. I'll write them again down here so that we can see them on our notes. F of x is 2x. G of x is x minus 1. Okay? So if we're saying 2 times g of x, I already know that g of x is x minus 1, so I just have to distribute my 2 and get 2x minus 2. And then my domain is all real, because it's a line. Does that make sense? Now, this won't always look this way. Sometimes it'll look like f of g of x. Sometimes it'll look like f of g of x. Like that. There's 2 different ways you can write it. Okay? But we can also do g of f of x. Whoops. So that looks like, starting with g, I put it anywhere there's an x, I put in an f of x. So f of x minus 1, but I know f of x is 2x, so I just get 2x minus 1. That's a line, so I know my domain is all real numbers. So that was a pretty easy one, right? Let's do one that may not be quite as easy. Let's do f of x x squared minus 6x plus 5, and g of x will be x plus 2. So first let's do fog. So f of g of x, like that. Can I fix something real quick? On the notes a minute ago, I accidentally colored in this circle that should not be colored in. It should look more like fog. Please forgive me. Okay? Thanks. So if I'm doing f of g of x, I'm starting with f. Anywhere there's an x, I'm putting in g of x. Okay? So g of x squared minus 6 g of x plus 5. Now some of you can not have to do this step right here. Some of you can totally skip this step. But if you're struggling with this, go ahead and write the g of x out. But like I said, some of you can go straight to this step because you already know what g of x is, and go straight here. I'm just making sure you understand all the steps you need just in case you're struggling with this. Is that all right? Okay. So if I have x plus 2 squared, what am I actually being asked to do? So x plus 2 times x plus 2, x squared plus 4x plus 4. That makes me happy that you say that, just so you know. Because you know what people a lot of times say? X squared plus 4. They forget to distribute like that. Okay, and then they miss it on the middle term, and then they basically can't get it right. So x squared plus 4x plus 4 is that term, this thing squared. Then I have to distribute the negative 6 and get negative 6x minus 12, and then I have my plus 5. So now it's just a matter of combining like terms, right? So I've got x squared. I don't have any other x squareds. I've got 4x, okay, minus 2x, and then minus 3. What shape is that? So my domain is reals. Negative to positive, right? Can you go the other way? G of f of x, or GOF. So it would be f of x plus 2. Well, f of x is x squared minus 6x plus 5, and then plus 2. So that one's almost too easy. It makes you wonder if what you did wrong, right? What shape is that? So my domain is all reals. You okay with that? What about f of x is, oh, excuse me, I'm going to start here. H of x is the cube root of x squared plus 1. Okay? It tells you what h of x is and asks you for f of x and g of x. What could we come up with for f of x and g of x to say that this is f of g of x? The h of x is f of g of x. It could be the cube root of x, and g of x could be x squared plus 1, right? What if it told you h of x was the square root of x squared plus 5? Could you figure out f of x and g of x from there? What would f of x be? The square root of x. And what would g of x be? X squared plus 5. That makes sense? Kind of going backwards of what we just did. Good? So that one was writing functions as compositions. So I gave you what the composition would be, and then you're identifying each of the functions that would go into that composition. Okay? So finding domain you feel confident with. Combining functions using the algebra of functions, so adding, subtracting, multiplying, dividing. Forming compositions of functions, determining domains of composition of functions, and then writing them as compositions. You good?